In the previous chapter, we saw the communication principle demonstrated. Now we will see where these methods were used in practice. I will first show the source code for the program LABCF. It corresponds to the demo program TSON. The LABCF code is, like most of the LABCA source text, stored in the global directory lab. There is a lot of global directories in the system. Let us see here, DL, here they come. That's a lot. But I will concentrate on lab where the source code are stored. So I write VD lab and a DL to look into. Here you can see there's a lot of subdirectories here, and each subdirectory contains source code for one LABCA program. I want to look in the subdirectory LABCF, so I write VD LABCF and a DL, and you can see here is all the Fortran module, but also the relocatable modules. And if I only want to see the source code, I write dl@.ftn. Here you see the main module labcf.ftn. These subroutines here are only used by LABCF. There are lots of subroutines which is common for all LABCA programs, and they are in another directory. It's called lablib. But let us first look at the LABCF ftn. So let us look at that code. Here you see the source code. You can see the priority is 49. It is a program equivalent to the SON. It's a kind of a kernel program. You can see it for common file handling. You see here there's an update for the year 85, but in fact this program is for 78, 79, but in the beginning we didn't write any. If we were updating, we think, oh, we can remember it all, it's not necessary, but it was necessary, so that was good. And you can see here there were more and more systematic, and there come more and more update. The last one is from year 2005. If you can remember the program TSON, it could have 3 functions, an open, a close, and something called BB. Here it's a lot more functions. Here it was the open, the close is still there. But let us see how many functions there are. So I will use the editor and write 1, 2. That means line 1 to last line, find all equal to, so here. And you see all this code to here. That's about around 30 different functions the program can do. If you look at the many if conditions, I can write 1 to $, find all if, like this. Yeah, that's about 90. So it's a rather complex program, a rather complex kernel program. This was about the source file, but what about the loader specification file and the run files? They are in another directory. Let us look there. It's called LABCA run. VD LABCA on. So let's take the there you see there are no subdirectories. There are only 2 types of files: a loader specification file and the run, the program as such. But there are many. If I want to see how many there are, I can write FOWN.load add .load. it's scanning. There are about 700 programs. Now I will try to restore LABCF. So I write RTE LABCF. And I will look at the program side here. And here I can see LABCF. It's a kernel program. It has a relatively high priority. It has a big data precision, 29. It can only beat 32, so it's very big. Very big. It has a co-partition on 64, and it is dormant. No, it is not shared. It's a kernel program. There's only one kind of this program in the system. All the terminals communicate with this kernel program. So let us look at the terminal program. And I can see, I will look at the source file for a terminal program. There is one, I could write edit x. It's in lab. And the subdirectory RKVIM. And it is called RKVIM.ftm. Here it is. This is a terminal program. You can see it's only have priority 80. It's a newer program. Here. You can see it makes lots of update. In fact, this program is larger than the previous program you saw. It's updated until year 2005. If we look at the loader file to this program, go into lab1 and I edit RKVIM. You see it only have priority 80 set here. It have a bigger stack. I'll return to about stack problems later. You can see here we load the main module here, RKVIM. Notice up here it's a shared program. It's a terminal program. And it have a lot of subroutines here. It's a big program. We are subroutines down to 9300. But I will try to restore this program then. And then we will look into the program section here. You can see RKVIM here, priority 80, that's correct. They lose a lot of data partition, the maximum size, but it have a co-partition which is rather large, 113K. LABCF only had 64. But it is, as you can see here, shared. And if you think of this feature in the RTE, that the program can be shared, like here, for a terminal program. You have about 60 terminals. If 30 or 40 of these terminals are running RKVIM, there is only one code session for this program. So you save a lot of memory. And also the system doesn't have to read big chunks of code from disk to memory each time the program starts up. Sharing a very nice feature in RTE A.